So we're going to have a little review here. We have a problem here, and it's two rational expressions. A rational expression, you might think of it like, oh, it's a fraction. It just means that the denominator is not necessarily a number, a real number, but it could be like an algebraic expression, like there might be a variable, and then in the numerator as well. But anyway, that's what we mean by rational expressions. And so we know we want to get a common denominator, right? Because we want to add them together. Okay, so we take in the first one, 2 times x minus 3, and we say, okay, let's multiply by x plus 2 in both the numerator and the denominator. And this is work you've done in the past in other algebra classes. And then the second expression, we have x plus 2 in the denominator, but we're trying to get common denominators, so we would multiply by x minus 3 in the numerator. And that was cool and everything. And then we said, all right, well, we'll go ahead and we'll distribute the numerator. So you get 2x plus 4. And then you have this common denominator going on, right? And then the other one, we get negative x plus 3. Okay, and then we said, oh, okay, now that we have common denominators, we can add those numerators. And so you take the 2x and you're adding it with the negative x to give you x, and then you're taking the 4 and the 3 and you're getting 7. You're combining like terms, right? Okay, so that's a little review of how you add with rational expressions. And so we get this lovely answer. Okay, it's one rational expression. It's got a numerator, it's got a denominator. Notice that in the denominator you have factors, but that's okay, even if we don't, but that's what that one looks like. Anyway, with partial fractions in a 9.4, we're going to try to go from this back to that. Okay, so they're going to give us an answer, and we have to figure out how to split it up into fractions that would add to b or subtract to b this answer here. Okay, so we're trying to go backwards on the system. All right, that's the idea behind partial fractions, or sometimes they'll say a decomposition of partial fractions. Partial fraction decomposition. So sometimes we just say partial fractions, and that's what we mean. But anyway, that's what we'll be doing, and it's all in the setup. It's all in how you set up the problems. And so I think there are 4 different examples we have of different setups.